Hi everyone. In this video, we'll talk about schemas, specifically, how measures and dimensions are arranged in a data mart during dimensional modeling. We'll focus on two common schema designs, the star schema and the snowflake schema. The star schema. The star schema is the most common and most recommended dimensional modeling design, especially for Power BI. It consists of one central fact table connected to several dimension tables, forming a structure that resembles a star, the fact table in the center with dimension tables surrounding it. Fact tables store numeric, quantitative data, often referred to as measures. Examples: sales amount, quantity, total cost, orders. Dimension tables store descriptive attributes used for slicing, filtering, and grouping. Examples: customers, products, dates, stores, etc. Now let's open our Power BI desktop file that supports this course and look at an example of a star schema inside Power BI. The file we'll explore is called Dimensional Modeling 1, which contains our star schema. When I switch to Model View, you can see the star schema clearly. In the center is our orders fact table. Surrounding it are the dimension tables. Dim date, date dimension. Dim customers, customer dimension. Dim stores, store dimension. Products, product dimension. I've intentionally arranged the tables to visually mimic a traditional star schema layout. Fact table in the middle, dimension tables around it. In reality, the physical placement of tables in the model view does not affect functionality, but organizing them this way helps illustrate the concept during training. Characteristics of a star schema. Simple and intuitive. Fast performance. Excellent for DAX and Power BI. Few joins required. Dimension tables are flat and wide, denormalized. Advantages of a star schema. Best query performance. Easy to understand and maintain. Fewer complex relationships. Recommended by Microsoft as a Power BI best practice. A snowflake schema is a more normalized form of a star schema. Normalization restructures a table to reduce data redundancy and improve data integrity by breaking it into smaller, related tables. For example, consider a denormalized product dimension table. In this table, values like smartphones and electronics appear repeatedly across many rows. This repetition leads to redundancy, inconsistency risks, and maintenance challenges. When we split the table into related subtables, each attribute is stored only once. For instance, smartphones can be stored once in a subcategory table, and electronics stored once in a category table. This reduces duplication and results in a cleaner data model. Snowflake schema structure. A snowflake schema still has a central fact table, but its dimensions are further normalized into subdimensions, giving the model a shape that resembles a snowflake. Now let's look at an example in Power BI. We'll open the file called Dimensional Modeling 2. Again, the orders table sits in the center as the fact table. Around it are dimension tables such as dim customers and dim stores. The product dimension, however, is normalized into a subdimension called dim category, making it part of the snowflake design. We can also see separate dimension tables for dim month, dim quarter, and dim year, representing different levels of a date hierarchy. In a snowflake schema, each level of a hierarchy is stored in its own dimension table, and the fact table typically links to the lowest level. Characteristics of a snowflake schema. Reduced redundancy. Smaller storage footprint. But more complex structure, more joins, and slower DAX performance. Advantages. Less data duplication. Clear and explicit hierarchical relationships. In very large models, normalization may provide some storage or refresh benefits. Disadvantages. More complex model structure. Queries can become slower due to multiple joins. Not recommended for Power BI because it increases complexity and reduces performance. To wrap up, the star schema is simple, fast, and ideal for analytical models. It requires fewer joins, delivers better performance, and is easier for end users to understand. It also aligns with Power BI best practices. And when building hierarchies, all hierarchy fields must exist in the same table, which the star schema naturally supports. The Snowflake schema is a normalized design that introduces more joins and greater complexity, making it less suitable for Power BI. Snowflake schemas should be avoided unless there is a strong reason to normalize. This brings us to the end of this video. In the next lesson, we'll explore how to create and manage relationships in Power BI. Thanks so much for watching, and don't forget to subscribe to support the channel.